Today's video will demonstrate how to implement the stack. Hello, I'm James Helfrich. There are basically four implementation options if you want to create your own custom version of the standard template library stack. This video will demonstrate each of those four options. The first option is use a fixed array. Here, a member variable will be an array, and we also have to keep track of the number of elements we currently have in the stack. Observe there are two template variables, T, which is the data type of the element in the array, and N, which is the size of the array itself, the maximum number of elements we can store in our stack. The second option is a list, where the underlying data structure is a standard template library's list, and we have exactly one of those. The third is a vector, and the final one is called a container adapter. In this case, we have two template variables, T, which is the data type of each element in the stack, and container, which is the flavor of the underlying data structure. It could be a list, it could be a vector, it could be a dect, or any other data structure you like. So let's take a look at the fixed array implementation. Here we have to know the maximum size of the stack at compilation time. So we have an array, which is going to be a base type T, and n elements, and n is a template parameter. And we also have to keep track of the number of elements that are currently in the stack. And the num elements must be less than or equal to n, our template variable. So our implementation is going to be template type name T, which is our base type, the type of each element in the stack, and n, the maximum number of elements. So I'm going to create an array of type T, and there's n elements. And I also have to have the int num elements. The pseudocode for push is going to make sure that my stack is not already full. If it is full, I'm just going to ignore it. Otherwise, I will add it onto the end of the array and then increment num elements by 1. The pseudocode for top will first assert that my stack is not empty, and then I'll return size minus 1. Notice if there are 10 elements in the array, then 9 is the last element, which is size minus 1. The pseudocode for pop is going to first make sure we're not empty. If we are empty, we're going to do nothing. And then I'm just going to simply ignore or forget about the last element by saying num elements minus minus. The list implementation option will have a single member variable, and that member variable will be a list. So the declaration will be std : list of T, which is my only template parameter. We'll just call that data. The pseudocode to push is I'm going to call list push back. The pseudocode for top is I'm going to call list back. And finally, the pseudocode for pop is going to call list pop back. In other words, the list is going to do all the heavy lifting for us for our stack implementation. The vectors implementation will look much like the list. We'll have a single member variable called std : vector of T, and it's going to have a single template variable called T. The pseudocode for push is going to call vectors pushback. The pseudocode for top is going to call vectors back, and the pseudocode for pop is going to call vectors pop back. Notice those are exactly the same methods we used for list. The container adapter is going to leverage the fact that vector and list use the same pushback, pop back, and back method names. So I'm going to have a single member variable called container. Notice I have two template parameters. One of them is T, which is the data type of each element in the stack. And the second one is container, which is the type of the container. My implementation is going to have a somewhat complicated template declaration. I have template type name T, which is going to be my base type of every element in my stack, and then my container. Notice how my container will be of type container T. The pseudocode for push is going to call the containers pushback. In other words, any container that implements pushback will work for this. The pseudocode for top will call containers back. Once again, any container that implements back will be able to use this. And finally, my pseudocode for pop is going to use containers pop back. Any container that implements pushback, back, and pop back can be used for my stack as a container attribute. We can learn more about the stack and various implementations options in the implementation section of the stack chapter of the C++ data structures textbook.